Our story begins not in a factory, but in the earth, with a drought-resistant root that feeds billions.
The first cut. The leafy growth is a byproduct, often used for animal feed.
Harvest is manual, relying on strength and care to avoid damaging the delicate, starch-rich tubers.
This is the old way. But on the other side of this plantation, AI is changing the game.
The mechanical harvester. Its efficiency is guided by GPS and yield mapping algorithms.
The data pinpoints variation. AI-driven scouting is dispatched to investigate.
The drone sees what the human eye cannot: early-stage disease or nutrient deficiency.
The response is immediate. The affected zone is quarantined, and the harvest path is recalculated.
The first journey begins. From field to processing, speed is critical. Fresh cassava deteriorates within 48 hours.
Their destination, a high-throughput processing hub, where the race against rot turns into shelf-stable product.
Every delivery is weighed and logged. Traceability starts here.
The first point of industrial scale. The roots are now in the system.
The first wash. High-pressure water removes the stubborn, baked-on mud.
Abrasive washing ensures no grit remains to contaminate the final flour.
Cleaned and weighed, the roots now enter the heart of the transformation process.
The last human check. Manual quality control is irreplaceable for removing spoiled roots. Their skin must be removed. Inside this machine, abrasive rollers will strip them bare in seconds. The abrasive peeling drum removes every trace of outer skin and bark, which can contain toxins.
Final inspection. Even a 99% peel isn't perfect. The last defects are removed by human eye and air.
Size reduction. Creating uniform cassava chips is critical for consistent drying and milling later.
The first drying stage. Steam drying uses less energy and helps begin the process of synovic glucoside breakdown, removing natural toxins.
Quality checkpoint. Moisture must be brought down to a specific level to prepare for the next, more intense phase.
They must be cooled before storage or milling. Heat here would cause moisture condensation and spoilage in the silos.
Final purification. Even a tiny metal fragment from machinery or stone missed earlier would ruin tons of flour and damage grinders. Here, the processed chips can be stored for months. This buffer allows the factory to run continuously, independent of harvest cycles.
Inventory is managed by software. A mouse click summons raw material from storage to the production line, the heart of the process. The hammer mill uses swinging metal hammers to smash the brittle chips into a coarse powder. The first grind. This is where the root truly begins its transformation into flour, through sheer mechanical force. Air classification. This separates the product from the grinding air and cools it down, preparing it for refinement.
Sifting or bolting. This is the separation of flour from grit and larger particles. Only the finest particles will become premium-grade flour.
The primary flour is born. Its texture and whiteness are the first signs of quality.
Blending for consistency. One sack of flour must be identical to the next 10,000. This mixer homogenizes the product from variable raw materials. The flour travels untouched by human hands. Pneumatic transport prevents contamination and maintains a dust-free environment. From root to retail package, the form-fill-seal machine is the gatekeeper between bulk production and the consumer unit.
Every single bag is weighed. Automated quality control rejects any under or overweight package instantly. The product, now boxed, has 1 foot in the factory and 1 foot in the outside world. Label application and verification. The case gains its digital identity for the logistics system. All lines feed the main artery. The packaging hall feeds the distribution hub. The sortation hub. Here, thousands of cases an hour are read and routed to their specific destiny. A unit of commerce is created. This pallet load is the standard building block of global shipping. Move to staging. The pallet awaits its final verification before being loaded onto the international container.
The last human audit, confirming that the physical goods match the digital shipment order perfectly.
Unitization. The stretch wrap protects from dust and moisture and binds the cases into one solid mass for handling.
Exit from the controlled environment. The product is now exposed to the elements, but only for the brief moment of transfer.
Secured for the ocean voyage. Load locks prevent shifting that could cause catastrophic damage during transport.
The world is sealed out. A climate-controlled container maintains the perfect environment for the flower's long journey. The handoff is complete. The factory's responsibility now transfers to the global logistics chain. Shipment monitoring begins. The factory tracks its product's journey from its own walls to the port. The factory never sleeps. For every pallet that leaves, 10 more are being built. The system is a perpetual motion. For every 1,000 bags, one is pulled aside. This is the quality control sample, destined for destruction by analysis.
Moisture content is critical. Too high, and the flour will clump and spoil. Too low, and it loses functional quality.
The functional test. This simple paste test reveals the flour's performance in final products like bread or noodles.
Spectroscopic analysis. In seconds, we verify safety and composition, ensuring the detoxification process was complete.
The falling number test. This determines enzymatic activity. A correct number means the flour will have the right viscosity for industrial food production.
Granular integrity. Perfect flour require undamaged starch granules. Broken granules can affect texture and absorption.
The micro debris check. Even after all the cleaning and sifting, the human eye under light is the final arbiter of purity.
The lab's verdict. With this signature, the entire silo's worth of flour, represented by this single sample, is cleared for human consumption.
Dust collection is not just for safety, it's for recovery. This filtered dust is still premium product.
Closed-loop recovery. Nothing is wasted. Even the air in the factory is mined for product, maximizing yield from every route.
Preventive maintenance. A single torn sifter screen could let coarse grit into tons of premium flour. It's checked every shift.
Analog vigilance. Even in a digital age, the power consumption of a mill is the best real-time indicator of its mechanical health.
All clear.
Predictive maintenance. Vibration sensors detect imbalances or bearing wear long before a human ear could hear a problem, preventing catastrophic breakdowns.
Even the packaging film is a raw material with its own quality control. It must be inert, strong, and seal perfectly.
Daily metal detector validation. This machine is the final guardian. Its sensitivity is tested with known contaminants to ensure it never fails.
Overweight is also a reject. Precision is paramount. Giving away excess product is the same as losing it.
Rework protocol. Nothing is thrown away. Even off-spec product is safely and systematically returned. Automated sanitation. During product changeovers or scheduled stops, the system cleans itself. The cycle resets. With a clean vessel, the core grinding process begins again.
The primary grind. This first impact shatters the brittle chips, breaking open the cellular structure to release the starch granules.
Air classification after the first grind. It separates the product from the transport air and cools the material, preventing heat damage.
Roller milling. This shearing action creates a more uniform particle size and generates less heat, preserving the quality of the starch.
Plan sifting. This is the heart of particle separation. It creates the distinct flour grades: fine, medium, and coarse.
Real-time process control. The product is analyzed continuously, and the upstream machines are tuned automatically for perfect consistency. The final micronization.
This step achieves the desired particle size distribution that will define the flour's performance in end-use applications.
Blending the streams. A single grade of flour is often a blend of different grinds, engineered for specific properties like water absorption or viscosity.
The final conditioning. Uniform moisture and temperature are critical to prevent caking in the bag during storage and transport.
The last line of defense. After tons of material have passed through steel machinery, these detectors guarantee absolute purity. Product handling engineering. Even the flow of powder into the bag is a science, preventing air pockets and ensuring accurate fill weight.
Dynamic storage. The system knows which pallet goes where based on its sell-by date and destination, orchestrating a first-in, first-out flow.
The pulse of the plant. Every gram of flour, every watt of energy, every minute of runtime is accounted for and optimized.
The cycle is endless. As the sun rises on a new harvest, the factory is already running, processing yesterday's yield into tomorrow's food.
The homogenization silo. Here, time and gentle motion erase the last inconsistencies, creating a single, perfect batch.
Particle size certification. This is the final, definitive check that the flour meets the exact specification.
Product routing. The single stream of flour now branches into its final commercial forms, each with its own packaging destiny.
Premium packaging. For the high-end market, the bag itself is an engineered barrier against light, oxygen, and moisture.
Secondary packaging. This adds physical protection and a premium unboxing experience, ready for retail shelves.
Palletizing for retail. The robot handles the product as delicately as a luxury item, which, in the world of specialty flours, it is.
20,000. Bulk loading for industry. For large-scale food manufacturers, flour is a commodity moved by the ton, directly from our silo to theirs.
Final staging. For the finest product, even the short wait before shipping happens in a perfected environment.
Tooling maintenance. The cutting edges that transform the roots are themselves constantly transformed, kept sharp to ensure clean fractures and consistent particle size.
Continuous improvement. The process is never static. Every day's data fine-tunes the next day's production.
Master cleaning protocol. The factory's daily rebirth. Hygiene is the invisible ingredient in every bag. Closed-loop water management. The factory is its own ecosystem. The water that cleans the cassava.
Shift change. The human rhythm of the factory. A new team takes stewardship of the continuous process.
System wake up. It's not just turning on machines, it's conducting an orchestra of interdependent processes to a synchronized start.
Global connectivity. The product is sold and allocated before it has even cooled, linked to the global food supply chain by data.
Order fulfillment. The digital reservation triggers a physical retrieval. The abstract becomes concrete once more.
The first leg of distribution. For premium product, speed is key. This flour will be on another continent within 24 hours.
The final transformation. The journey ends where it was always meant to, in the hands of a creator, where it becomes nourishment, culture, and craft.
The factory's digital twin. Every physical process has a virtual shadow, monitored for perfection.
AI-powered vision systems. They don't just watch, they diagnose, predicting failures from milliseconds of hesitation.
Autonomous material handling. The first human contact is eliminated. Vehicles are routed by an algorithm that maximizes throughput and minimizes wait time. Closed-loop quality assurance. Sampling and analysis are fully automated, providing constant feedback to adjust the mills and dryers in real time. Human-robot collaboration. The robots are powerful but aware. They work alongside people, adapting in real time to their presence. Predictive analytics. The system hears the whisper of metal fatigue long before it becomes a scream of breakdown, scheduling repairs and planned downtime.
Lights out warehousing. Pallets are stored and retrieved by robots in the dark, a monument to efficiency and energy savings.
AI energy arbitrage. The factory is also a power plant and a smart grid node, thinking in megawatts and euros per ton.
Optical character verification. Nothing leaves this factory with imperfect identification. Traceability is non-negotiable.
Internal drone surveillance. It patrols spaces too large and dangerous for frequent human entry, ensuring nothing is amiss in the stored raw materials.
The automated laboratory. Repetitive, precise science is handled by robots, freeing human experts for analysis and problem solving.
The automated scheduler. It is the brain of the operation,
juggling 1,000 constraints to maximize output and minimize cost.
Environmental monitoring robot. It ensures the workplace environment remains safe and that product isn't lost to the air as dust.
Waste becomes energy. Even the factory's wastewater is managed by AI, transforming a cost center into a source of renewable fuel.
Global Logistics AI. The factory's intelligence doesn't stop at the gate. It tracks and optimizes the product's journey across the planet. The virtual testing ground. New ideas are proven in silicon before they ever risk real product, accelerating innovation without risk.
Touchless sanitation. The factory cleans itself between shifts, achieving a level of consistency and hygiene impossible with manual methods.
The fully realized vision. A factory that sees, thinks, and acts, where the human role is not to
Morning calibration. Before the first bag is made, every machine confirms it is perfectly aligned for another day of precision.
Micro-precision filling. The difference between profit and loss, and between compliance and rejection, is measured in tenths of a gram.
The all-seeing eye. Machine vision scrutinizes what human quality control could never consistently see at this speed. High-speed pick-and-place. This is packaging at the limits of physics, where acceleration forces are calculated to handle the product without damage.
Tamper-evident sealing. The final unit of sale is secured. This unique code links this box back to its exact second of production.
Pallet branding and instruction. This label tells every handler, human or machine, exactly what this is and how to treat it.
The dispatch airlock. The product never leaves the cold chain. It moves from production climate to shipping climate without exposure to ambient conditions.
Automated dispatch verification. The system confirms that the right product is in the right place, preventing costly shipping errors.
The handoff to global logistics. The container is a mobile extension of our factory's climate control.
Loading precision. In the confined space of the container, every millimeter counts. Secure fitting prevents shifting during transport. Sealed for the journey. For the next 36 hours, this environment is its entire world.
Intercontinental leap. The product is in a state of suspended animation, crossing continents while its quality sleeps, preserved.
Local integration. The global journey ends, and the final mile begins. The product enters a new logistical network.
Cross-docking. The pallet is broken down. The unit changes from a bulk shipment to individual retail boxes for store shelves.
The last mile. The product is now in the hands of local retail distribution, hours away from a consumer's shopping cart.
Final placement. The industrial journey concludes here, on a humble shelf, waiting to be chosen for someone's kitchen.
The retention sample. For every batch that leaves, a piece is held in frozen custody, awaiting its day of judgment in the lab. Sample preparation. Creating a perfect suspension is the first step to revealing any microbial secrets hidden within the flour.
Cultural plating, the oldest and most reliable method. We create ideal conditions for any contaminant to grow, if it exists.
The incubation wait. Time is the essential reagent. We give any potential life form the perfect environment to reveal itself.
The result is negative. The flour is microbiologically sterile, a testament to release.
Digestion for elemental analysis. We reduce the complex organic matrix to its basic atoms to search for unwanted guests, please. ICP-MS screening. This machine can detect parts per billion, a single grain of salt in an Olympic swimming pool. Final toxicology check. This confirms the roasting and drying processes successfully broke down the cassava's natural defense compounds, making it perfectly safe. Rheological testing. This tells us how the flour will behave in a real bakery. Its water absorption and stability are plotted, defining its functional character. Quantitative particle size. This is the final word on fineness. The curve must be perfect to ensure consistent performance in industrial food production.
The digital dossier. Every test result converges here into a single, authoritative document that...
Batch hashtag 7742 is fully cleared. You can release the shipment.
The release call. Science gives the green light.
System-wide release. The digital permission propagates instantly, unlocking the physical product for the logistics chain.
Está perfecto. The organoleptic finale. Data is confirmed by sensors.
The client's assurance. The COA travels ahead of the physical shipment. The buyer knows with scientific certainty.
The physical archive. In the digital age, a tangible, signed record endures. This
production. Validated. The line is more than a machine. It is the physical manifestation of a promise.
The twin pillars of trust, invisible safety and tangible expertise. One cannot exist without the other in the modern food system.
The final packaging surge. With quality assured, production hits its maximum, efficient pace, transforming bulk powder into countless saleable units.
High-density palletizing. Every case is positioned for maximum strength, minimizing empty space and securing the product for the long haul.
Weatherproofing. The pallet is sealed against humidity and dust, ensuring the product arrives in factory-fresh condition.
High-density storage. The product is archived in a digital physical matrix, where robots are the librarians, and every pallet has a perfect, known address.
Dynamic order fulfillment. The warehouse is a living system. Storage is temporary. The constant flow of retrieval and dispatch is its true purpose.
The loading dock interface, where the controlled factory environment meets the open road. The transfer must be swift to maintain the cold chain. Load securing. The forces of acceleration, braking, and cornering are calculated and countered. A shifting load is a damaged product.
The seal of custody. This broken seal is the only proof of tampering. This number transfers legal and physical responsibility to the carrier.
Departure. The product's relationship with the factory changes from one of creation to one of lineage. It carries our name, our standards, but now moves on its own path.
The digital handshake. The customer is notified in real time. The supply chain is transparent, from our floor to their door.
Entering the global stream. The product merges with the vast river of global commerce, its environment still controlled, its identity still precise within the chaos.
The journey recapitulated. From sun and soil, through engineering and science, to a packaged promise of nourishment.
The closing statement set up. The person who orchestrates the daily miracle steps forward to explain it. And this is how modern factories produce cassava flour from start to finish. The mandate line, delivered not as a sales pitch.
The final revealing scale. The facility is shown not as a collection of machines, but as in
context and scale. A reminder that industry, no matter how advanced, sits within and serves a wider natural and human world.